friends, myself Tina. These are my friends Reena and Leena. Today we are going to discuss here a topic, electric energy generation using solar energy. First, we will present here a table which shows different types of power plants, the source of energy and energy conversion in these power plants.
So this is a table which shows different types of power plants which we have already studied. So here the thermal power plant, it uses coal as a source of energy, and the energy conversion which takes place here, it is the chemical energy in coal, it is converted into heat energy by the process of combustion. And here the heat energy which is liberated in the process of combustion, it is used to generate the electricity by the process of electromagnetic induction. Second is the nuclear power plant, and here the source of energy, it is uranium or plutonium. These are the radioactive elements or heavy elements, and these elements undergo the process of nuclear fission, and in this process of nuclear fission the energy which is liberated, it is in the form of heat energy. This heat energy which is liberated due to the nuclear fission process, it is used to generate electricity, and again the principle used here, it is the principle of electromagnetic induction. Third is the natural gas power plant which uses compressed natural gas as a fuel, and here the combustion of this compressed natural gas, it releases heat due to conversion of chemical energy in this compressed natural gas into heat energy, and this heat energy which is liberated, it is used to generate electricity, and again the principle used here, it is the electromagnetic induction. And lastly, windmill and hydel. Windmill and hydel, as we have already studied, are a clean source of energy, and the energy source used here in a windmill, it is wind, that is the kinetic energy in wind, it is converted into electrical energy, whereas in hydel, that is hydroelectric power station, flowing water is a source of energy. Here the potential energy in water which is at a height, it is converted into kinetic energy in flowing water, and then electrical energy it is generated, and again the principle which is used here, it is the electromagnetic induction. This means that all the power stations, thermal power plant, nuclear power plant, natural gas power plant, windmill and hydel, they use the principle of electromagnetic induction for generation of electric current, and this is done with the help of a device which is known as electric generator, which we have already studied. But electricity generation from solar energy, it is done by two different ways. First, by using this electromagnetic induction, that is electric generator is used, and secondly by using this photovoltaic cell where electromagnetic induction it is not used in this process. In short, use of solar photovoltaic cell and use of electric generator are the two different ways by which solar energy can be converted into electrical energy. So let's discuss here the first method in which a solar photovoltaic cell it is used in details. In short, use of solar photovoltaic cell and use of electric generator are the two different ways by which solar energy can be converted into electrical energy. So let's discuss here the first method in which a solar photovoltaic cell it is used in details. So here we are going to analyze the information which is provided to us in the textbook, and analytical reading it is very important here.
I have formulated a question here. What is a solar photovoltaic cell? A solar photovoltaic cell is a device that converts the solar radiation energy directly into electrical energy. In this manner, solar photovoltaic cell converts the solar radiation energy directly into electrical energy, and this is called as solar photovoltaic effect. The nature of electrical energy generated is of DC type. Type of material used, it is a semiconductor. Example, silicon.
Now here is a statement. A silicon solar cell of dimension 1 centimeter square generates current of about 30 milliampere and potential difference of about 0.5 volt. Then what if the solar cell has dimension 100 centimeter square? तर एक लक्षात घेऊयात आपण इथे की एखादं जे स्टेटमेंट असेल जे अतिशय मोठं असेल किंवा त्याची भाषा आपल्याला लक्षात येत नसेल, सो वी विल डिवाइड दिस स्टेटमेंट, वी विल डिवाइड दिस इन्फॉर्मेशन इन दिस स्टेटमेंट फॉर अस टू अंडरस्टँड. तर लक्षात घेऊयात आपण हे पॉईंट्स जे आपण इथे दाखवलेले आहेत, आपण डिवाइड केलेले आहेत. सो एरिया, current and potential difference. These are the focusing words in this statement, and here the area of this cell, if it is 1 square centimeter, then the current which is generated, it is 30 milliampere and the potential difference, it is 0.5 volts. Now that we have written it in this manner, म्हणजे अशा पद्धतीने आपण हे लिहिल्यानंतर आपण युनिटरी मेथड यूज करूयात. 5th स्टँडर्डला झालेली आहे, 6th स्टँडर्डला झालेली आहे. ओके, तर मग इथे 1 स्क्वेअर सेंटीमीटर इफ इट इज द एरिया ऑफ अ सोलर फोटोवोल्टिक सेल, इट गिव्स अस अ करंट 30 milliampere. Then how much current will be generated if the area is 100 square centimeter? म्हणजे आपण काय करणार आहोत इथे युनिटरी मेथडने, 30 milliampere, it will be multiplied by 100 and 30 into 100, it is 3000 milliampere, and 3000 milliampere, it is nothing but 3 ampere. आता काही गोष्टी ज्या असतात त्या बेसिक असतात मॅथमॅटिक्समध्ये किंवा युनिट्स वगैरे जर आपण पाहिलं तर हे मिली ॲम्पियर म्हणजे 1 ॲम्पियर इट इक्वल्स 1000 मिली ॲम्पियर हे आपल्याला लक्षात यायलाच पाहिजे बिकॉज वी आर 10th स्टँडर्ड स्टुडंट्स. ओके.
Yes, miss. We have followed it. Miss, but I have a doubt here with the statement. Remember that the potential difference available from a solar cell is independent of its area.
Okay. Remember that the potential difference available from a solar cell is independent of its area. अतिशय सिंपल असं हे स्टेटमेंट आहे. ओके. तर 8th स्टँडर्डमध्ये असताना आपण ड्राय सेलचा स्टडी केलेला आहे अँड ड्राय सेल इट प्रोव्हाइड्स अ पोटेन्शियल डिफरन्स ऑफ 1.5 वोल्ट. मग आता इथे वेगवेगळ्या साईजमध्ये ड्राय सेल यू कॅन व्हिज्युअलाइज हिअर. आणि मग लक्षात घ्या की या ठिकाणी हे जे वेगवेगळे साईज आहेत, इवन इफ द सेल इज अवेलेबल इन डिफरंट साइजेस, what about the potential difference? The potential difference, it is always constant as far as dry cell it is considered. And the same thing is here, okay?
Yes, miss. We have followed it now. That as long as the cell it remains the same, the potential difference available from that cell, whether it is a solar cell or a dry cell or any other type of cell, the potential difference it remains the same. So in short, energy in sunlight, it is converted into DC electric power and this is known as photovoltaic effect. Now let's see the combination of solar cells. The solar cells, they are connected either in series or in parallel. Figure 5.23 shows the arrangement of solar cells in series, whereas figure 5.24 it shows the arrangement of solar cells in parallel.
So let's point out the differences here. The solar cells, when they are connected in series, the potential differences of the individual cells are added. And when the solar cells are connected in parallel, the potential differences remain constant, that is, they are not added. When solar cells, they are connected in series, the current, that is I, it is equal to I1, which is equal to I2, whereas when the solar cells are connected in parallel, then the voltage V is equal to V1, which is equal to V2. For a solar cell connected in series, V is equal to V1 plus V2, whereas for a solar cell which is connected in parallel, I is equal to I1 plus I2. This combination of solar cells in series and the combination of solar cells in parallel, it is used to generate the required amount of electricity and to withdraw a required potential difference from the solar photovoltaic cell.
Now let's study how the solar cells are connected.
Figure 5.25 shows a solar panel made from 36 solar cells. If 36 solar cells, each of a size 100 square centimeter, are connected in series in a solar panel, they give a potential difference of 18 volt and a current of 3 ampere.
Yes, as each solar cell has a voltage of 0.5 volt, then 36 solar cells which are connected in series, they will yield a voltage of 18 volts. As the area of each solar cell it is 100 square centimeter, the solar cell generates an electric current of 3 ampere. Solar array is formed when solar cells are connected.
Figure 5.26 shows how the solar cells are connected. Solar cells are connected to form a solar panel. These solar panels, they form solar strings and then a solar array.
Thus, solar cell is the basic unit in solar electric plant. Many solar cells come together to form a solar panel. Many solar panels are connected in series to form a solar string, and many solar strings are connected in parallel to form a solar array, and therefore we can obtain as much current required by using the solar cell. Now let's study the significance of solar energy, that is, importance of solar energy.
I have marked here a few points related to the efficiency of solar energy. The first point here is of the efficiency of a good solar cell. Efficiency of a good solar cell is 15%. It means that when 100 watt power is received from the solar radiation, then the electric power generated from the solar panel, it is 15 watts. Secondly, electric power is obtained according to the requirement. That is, electric power ranging from milliwatt capacity to megawatt capacity in power stations. Third point is direct use of energy. The power which is available from solar cells is direct current, that is DC. Thus, this direct current can be used in appliances which need a direct power supply, for example, light emitting diodes. Fourth, storage of energy. Energy from solar cell, as it is available only during daytime, therefore we can store this energy in batteries for further use. Next is conversion of DC power to AC. Inverter can be used to convert the DC solar power to AC power. Sixth point is that no fuel combustion is done to generate electricity and therefore it is a clean source of energy.
Yes, but solar energy has a limitation that the energy is generated only when solar radiations are available, that is, only during daytime.
Figure 5.27 shows energy conversion, that is, how the direct current it is converted into alternating current. So here a solar cell it generates electric current. This electric current is stored by battery, and then inverter is a device which converts the direct current into alternating current. Similarly, figure 5.28 shows schematic of solar photovoltaic station. Here, light energy, that is energy from solar radiations, it is absorbed by solar array, and these solar array convert this light energy into electric energy. And an inverter is a device which transforms this direct current which is generated into alternating current. And lastly, there is a transformer which transforms the voltage and current levels of the generated power, and then it is fed into the electricity distribution network.
So this was a discussion related to the solar photovoltaic effect and use of solar photovoltaic cell. And now we are going to discuss about solar thermal plant.
We have already studied that thermal energy is generated from coal and nuclear fuel, and it is used to generate electricity. In the same manner, thermal energy can also be generated from solar radiation, and it can be used for electricity production.
Figure 5.29 shows different stages in solar thermal power plant.
Here, sunlight is concentrated with the help of concentrators. It is absorbed by absorbers, and this absorbed sunlight, it is used for boiling water. This water, which is converted into steam, it is used for rotation of steam turbine, which is in turn connected to an electric generator, and it generates electric energy.
Figure 5.30 shows schematic of a solar thermal power plant. In this solar thermal power plant, there are many reflectors that reflect and concentrate the solar radiation on the absorbers. And here, the solar energy, it is converted into heat energy. This heat energy, it is used to boil the water and convert this water into steam. This energy of the steam is used to drive the turbines. The turbines are in turn connected to a generator, and in this manner, electric energy is generated. So this is all about how solar energy it is used to generate electricity. And this is all for today. Have a good day.